Welcome to solving coding interview problems. And today, let's look at the two-sum problem. So given an array of integers, we are to return indices of two numbers such that they add up to a specific target. You may assume that each input will have exactly one solution, and you may not use the same element twice. So going through the umpire method, you want to understand the problem. Okay, we're given 2, 7, 11, and 15. So we want to know, and we have a target of 9. So then we need to know what are the two numbers in the array that's going to give us the target, and we'll return the indices. So some clarification questions will be: 1, what about if we have an empty array? What will happen? Well, you should expect that maybe that scenario will not be possible. What about if target is 0? What should we return? And we should expect that maybe target will not be 0. And is it possible for the array to be sorted? Well, we should expect that maybe it will not be sorted. And can we have duplicate in the numbers? Because a given array return it so that they add up to a specific target. You may assume that each input will have exactly one solution. You may not use the same element twice. So, well, we could have duplicate in the nums in the array. Okay, and we cannot use the same element twice. All right. So, and way to look at the problem is let's try to give some example cases and see how it's going to look like. So 1, if we have 2, 7, 11, 15, and the target is 9, so our output will be 0 and 1. So it will be this and this. So our result will be 0, 1. What about, let's say we have they've told us we have exactly one solution. Let's say we have these 2, 3, 1, and our target is 3. Well, this is an interesting case. We cannot just return 3, so we have to return 2 and 1, which will be at index 0 and 2. Let's try one more. If we have an array of, say we have 1, 1, 2, 0, and the target is 2. In that scenario, we expect our result to be not 1 and 1 because we can't use the same element, not only 2, but we can use 2 and a 0. 0, 1, 2, 3. That will be our result. Okay. So, what's the best way of solving this problem? We can solve this problem by using the complement approach. So, for instance, in the first one here, once we see 2, we want to check in the data structure whether we have a need for 2. Maybe we are looking for 2. If we are looking for 2, then we return. So we can keep a data structure which we are going to call let's say is sin. We call it sin, which is going to be a dictionary. So essentially what we're trying to do there is, once we get to 2, we want to see whether we're looking for 2. Okay, so there's nothing in our dictionary, so we're not looking for 2. Then we had, if we are not looking for 2, then what we will be looking for? 2, 9 minus 2, 7. So we add 7 to the dictionary, and the current index is 0. Then we move to 7. Then we check in our dictionary, are we looking for 7? Yes. So, and we have found 7 now. Then we can return both the index in the dictionary and the current index. Let's try it another way in this place. So in 2, we say we have sin is a dictionary. Then we get to 2. We check in our dictionary whether we're looking for 2. No, we're not looking for 2 in our dictionary. So we add the difference between 2 and the target to the dictionary, which is 1, and we had the current index, which is 0. Okay, then we move our pointer to 3. Now we check in our dictionary whether we're looking for 3. No, we're not looking for 3. What we're actually looking for is 1. So then we check the difference between 3 and the target, which is 0, and we add 0 to our dictionary and the current index, which is 1. Then we move our pointer to 1. Then we check in our dictionary whether we're looking for 1. Yes. Then at that point, we return the index in the dictionary and the current index. Finally, let's look at the third one. We start our array from 1. Our target is 2. We check in our dictionary whether we're looking for 1. No, we're not looking for 1. Then we store in our dictionary the difference between 1 and our target, which is 1. Okay. But in this case, we run to a problem because by the time we get here, we see that we are looking for 1 and we'll be using the same 1 twice. So to avoid that problem, the first thing we need to then do is rewrite our array with only unique element. So then we can now start from 1, the first element, and we check in our dictionary whether we are looking for 1. No, we're not looking for 1. Then we check the difference between 1 and the target is 1, and we add the index to our dictionary. Then we move to the next element and we check whether we're looking for 2 in our dictionary. No, we're not looking for 2. We look for the difference between 2 and the target and we store it in our dictionary. Then the next is 0. Then we check in our dictionary whether we're looking for 0. Yes, we're looking for 0. At that point, we return the index in our dictionary and the current index. Make sense? So let's now see how we can code this. So let's do the coding now. So to code this, we will okay, we have a function f to sum and we're receiving nums and target. So the first thing we do is we turn our nums into a set. So we can do nums the set and use set function to turn it to a set to remove the duplicate. And then we'll keep a dictionary of scene, which is a dict. Then we iterate through our num. So for num in num set, we get the difference between the target and the num, and we check if the current number is what we're looking for. So if sin dot get the current number, if it's not none, that means the current number is what we are looking for. If it is not none, then we return a list of the index of that current number from the dictionary, which will be sin num and the current index. So in a way, we'll need to adjust this a bit. Because we need the index. So let's adjust this a bit and use enumerate here. So we can say for I, nums in enumerate the num set. Okay, so that can give us the index we need. So this should be num. So sin num and the current index will be high. Else, if it is not there, then we add its complement. To the and the index. Yeah. So let's now do a walkthrough based on our examples and see whether this works. If there's anywhere we need to modify. So using the running example of 2, 7, 11, and 15, and a target of 9. So let's see if we can catch our errors. So by the time we do the num set, this still remains the same because we don't have any duplicate. Then our sin is empty dictionary. I'm getting here, I is 0. Num will be the first element, which is 2 in our array. So we are now here. Then we take the target, which is 9, minus the norm, which is 2. So this gives us 7. Okay. So we now check in our dictionary if sin.get 7 dot get norm is 2 dot get 2. If it's not none, in this case it is none, so we go to the else, then we add it. So our sin at this point will become a dictionary with a complement 7 and the index is 0. Okay. Then we go back to the for loop, which iterates from 2. We are now here 7. Then our I will become 1. Our norm is 7. Our target is still 9. Our norm is 7. The difference is 2. So our C is 2. Then we say if sin.get, our norm is 7, is not none. Then we check in our dictionary, we can see that we're looking for 7. Then we return sin 7, which will give us 0, and our current I, which will be 1. Then this will be the end. So let's take a moment to pause and type in the code, and we can see how it works. So we pause. And welcome back. So here is our code, just like we have explained, and it's been accepted. Thank you very much, and see you in the next one.